Okay, welcome to, I believe, my last video of 2015 for the 1DE Reach Ed Math class. It's been a blast, and I've been through 3 or 4 computers and 4 or 5 pieces of software. Hopefully you've enjoyed the videos and they've been helpful. So this is the EQAO open response or long answer response. This is the video that goes after the multiple choice video. So in between, I don't know if you can see this, but this is question number 13 from the 2014 exam. So you would have 12 multiple choice questions, and then you come up to 3 or 4, I think it's 4 open response questions. So then you do those, and then more multiple choice, and then more open response, and you're all done. So let's look at this here, strategies on how to attack this. One, you got to read carefully. So I've already read this, but you're going to take your time and read this here. And it's talking about Rachel planting trees. She gets paid 55 bucks a day and 15 cents per tree. So N is the days, E is the dollars. I'm not sure why. It's earnings, I guess, for the amount of money. And we're going to graph what's going on here. Here's total earnings. Here's the number of tree planted. And we're going to talk about, we're going to just need a couple points. It's a linear relationship. Okay. So she gets paid something. Let's just think about this real quick. She gets paid something a day, 55 bucks a day. And then each tree she plants, she gets 15 cents and 15 cents and 15 cents and 15 cents and 15 cents. But we're going to look at the scale here and help us out. So first of all, if I want to get 2 points, if I have 2 points, if you have 2 points, you can draw a line. That's just the way it is. And the nice thing about this one is we're told that she gets $55 a day. So if she gets paid 55 bucks, that means she planted no trees. So she shows up to work, she won't keep her job for long, but she'll get paid $55. So at 0, I want to go to 55, but there's no scale here. So let's just hold off on this for a second before we plot a point. Let's try to figure out where our second point is and try to make something that's going to fill up close to this whole line. Okay, just some advice. They don't want this to be your answer. They don't want you to use the scale, so that's your answer. They also don't want this to be an answer. Okay, or this. Okay, you want to try to fill up the majority of the graph. Okay, so we have number of tree planted 100, 200. You might want to figure out how many. 100 is just a nice number. Okay, so if I say she planted 100 trees, well, if she planted 100 trees and she gets 15 cents a tree, then she gets that times that, which is 15 bucks. So she gets paid $15 for 100 trees. Okay, so she gets paid $55 plus the 15, and add those together, and you get $70. So at 100, I got to be at 70. What about 200? Just for fun, let's see what's 200's at. If she planted 200 trees at 15 cents a tree, okay, I could put a 0 here. She gets paid an extra 30 bucks, and 30 bucks plus 55 is going to get me to 85 bucks. So that's up 15, up 15. I got a nice linear relationship. So if I want 200 to be at 85, well, 100 is close to that. So I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2, 3, 4, 5, 6, 7. I got about 20 here. So if I want to get up to 100 bucks at 200, maybe I go by every other one's 10. So 10, 20. And if you mess this up, you just erase and start from scratch. Okay? And even if you don't mess it up, but later on you look at it and you say, hey, oh, what did just happen here? That's a mistake. See, that's a mistake. Okay, my eraser is a little different than yours. Space 50, space 60, space 70. Let me just do this right there. 30, 40, 50, 60, 70, 60, 70, 80, 90, and 100. So this is going to be nice. So I'm going to plot the point 0, 55. So 0 goes with 55. You want to use a broken line? You can. I wouldn't bother. But there's 0 and 55, between 50 and 55. 100 goes to 70. So 100 go up, and there's 70. And then you're going to use a ruler. I don't have one. And you're going to connect the dots and then extend it through here, and you would hit the 285. 285 is right here. So if it's a straight line, it'll hit there. Okay, so that's that. Write an expression and the number. So you want the expression also. So it's y equals mx plus b. That's our normal expression. But we're not using m's and b's here, or y's. Sorry, we're not using y's and x's. Our controlled variable or independent variable is n. So I have n. And my earnings is my dependent. So usually x and y. X is replaced by n, y is replaced by e. E is equal to something times the number of trees. We said it's 15 cents. And b is my initial value or my intercept, and we said that's 55. Okay, so e is that. You don't have to define anything because it's already defined for you as far as the dollars and trees and all that stuff. Let's go to the next one. This one I'm going to go a little bit quicker through. Show you how to set it up, but I won't finish it for you. Here I want to find the initial amount of water. So I want to find the initial amount of water. Here's a bunch of water, and it gets, you have a scenario here. Water in a pool and it's drained, so there's a bunch of water and eventually you have no water. Okay, so at a certain amount of time, at 70 minutes, we have no water. How much do we start with, and what's our rate of change? Well, the rate of change is the one you're going to find out first. You have 2 points here. You have the point. So again, this is independent. This is my x, this is my y usually. So usually I go x, y. But now I'm going to go t and a here. So t goes here and big A goes there, okay, for amount of water. So here my point can be 20. Here I have a point 20, 45,000. So 20, 45,000. And here I have the point nothing, 0. And I have nothing. That's not true. So I have the point 70, 0. So if I want to find the rate of change, it's my delta y over delta x. Or I could look at this and say, look, it's my 45,000 subtract 0 over 20 subtract 70. So I'm going to take this one, subtract this one over this one, subtract this one. You could do the other way around. You're going to end up with a negative. Figure out what this is. That's your rate of change. Then after you get your rate of change, that's your m. You're going to then sub that in for m. So this guy goes here. You're going to sub that in. And now I need to find b. So I need to find, that says need to find b. And to do that, to find b, what you'll do is you'll sub a point. So the easier point is 70, 0. You're going to sub the point 70, 0 into this equation. A equals m times t plus b. So again, y equals mx plus b. X is replaced by t. Y is replaced by a. So then you go, this is your xy or your ta. And then this is a, so this is 0. So m, whatever m is, times 70 plus b. That'll be a number. Bring it over and solve for b. Okay? And then that's your initial value. And okay, so that's that question. You want to keep going. A lot of linear stuff in this one. And you say, Lucia and Paul each have a plant. This is Lucia's plant growing. This is Paul's plant growing. And if you scroll down, the question is, which one is faster? And justify your answer. So which one's growing faster? It doesn't necessarily say which one is bigger. So be careful with that, okay? It's faster. And what you want to do is look at the rate of growth. So here, my rate of change is going to be, I have 2, and here I have 3. So again, you go delta y over delta x. You can call this x and y. You can change it. You can change it to h and d if you want. But what you're going to do is that's y2 subtract y1 over x2 subtract x1. There's a couple ways to do this. And you could say that's going to be 10 subtract 8. No. Yeah, sorry. That's right. 10 subtract 8 over 7 subtract 4, which is 2 over 3. And then you ask yourself, does that make any sense? Well, it grew 2 centimeters in 3 days. So it grew 2 centimeters in 3 days. So the rate of change is 2 centimeters over 3 days. Now, does Paul beat that? So that's Lucia's story. Does Paul beat that? And one thing you got to see right here is, and I didn't catch this the first time I did this, is the scales. This is going up by 1 here. Okay, you want your delta y over delta x, but this is not going up by 1. This is going over by 2. So when I'm going to say my delta y is 1, 2, 3, 4 for my slope, okay, I'm going up 4, and then I'm going to say, oh, I went over 2. That's wrong. I went over from 10 to 14, and be careful. They do this sometimes on these EQAO tests. So 4 over 4 is 1. So this is 4 over 4, which is 1. If you'd gone 4 over 2, you'd still say that Paul's winning, but your answer would actually be wrong. You'd probably lose marks there for having the wrong actual data. So here she went from 7. Let's just see if this makes sense. On day 10, it was 7 centimeters, and then on day 14, it was 11 centimeters. So it went from 10 to 4. That's 4 days, and it took 4 days to grow from 7 to 11, 4 centimeters. So 4 centimeters divided by 4 days gets me to 1 centimeter per day. Okay, so there's your work. You'd make it look a little nicer than that. Okay, so then you would say Lucia. Here's Lucia's work. Here's Paul's work, and then you would work it from there. Okay. Lovely lines. Line 1 shows on the grid below, is shown on the grid below, and it says here line 2 passes through the point negative 10, 8. So negative 10, 8 is here. and it has a slope that's triple, or 3 times this slope here. So you want to find this slope here. You want to make sure slope's not hard to find. You just got to make sure that the points you use intersect both x and y at the same time. So here I have this one. I just like to use zeros. It just makes my life a lot easier. So here I have 0. I have the point here, which is going to be 0, -3. And this point here is the point -6, 0. So my delta y over delta x, you want to find, so this is for line 1, delta y over delta x is going to be -3 subtract 0. So I go this, subtract this, over 0, subtract -6, which gets me -1/2. -3 over 6, which is -1/2. Does that make sense? It's negative because it's going down. It's a little bit flatter than usual, so it's you know, it's not 1, so it's -1/2. Does that make sense? Let's figure this out again. So if I go up, down 1, I go over 2. Yep, that makes sense. And check my scales here. This is 0, 1, 2, 3, 4. This is 0, 1, 2, 3, 4. So each line is equivalent to 1. So the slope of line 1 is -1/2. Line 2 slope is going to be 3 times -1/2, which is then going to be -3/2. So 3 times is big. Don't get confused with the negatives. So here's my point here, and I want a slope of -3/2, which means I go down 3, 1, 2, 3. So I want to put that I went down 3 and show this. And then I'm going to go over 2, 1, 2 and plot that point there. Okay. Then when I connect these 2 points with a line, with a ruler, okay, straighter line than that, you're going to have something that looks like that. It'll be 3 times as deep. Okay. The other thing you could do is find a point. It is work your way through and show what the next point is. I don't necessarily know if you have to do that. I would say I would find the slope, and then I would say I would then find the coordinates of this point and say this. Look at the graph, see above. My next point is then going to be what? I made a big mess of that. So if it's 3 lower, so this was -10.8, right? Is that right? -10.8. -10.8. So I want to go 3 lower. I get to 5, and then I'm going to go in 2, so I get to -8. So my point's -8, 5. Okay, and there's my point there. Okay, so that's that. Here, the cone part, I'm running short on time. What you're going to do is find the overall volume, and then after that, find this volume. Okay, if this is 8, that's 9, that's 3. Find this volume, subtract the 2. Use your equation. We get to this one here. I have a 10-sided figure. I want to find x, and then I want to find y. A 10-sided figure has 10 minus 2 times 180 is equal to 1440. This is not going to be given to you, but you need to know that n minus 2 times 180 will get you the total number, the total sum of the interior angles of an n-sided figure. So that is 8 times 180 is 1440. 1440 is the total, but there's 10 sides, so each one is 144, and then you put your answer below. Make sure you show your work here. Okay, I'm not doing that because I can't access the whole page here. Over here, if that's 14 degrees and these are equal, then these are equal. So 180 subtract 14 is 166. Okay, and then you know that these are all congruent. That's 14, that's 14. So that's 166 for the other two. Divide by 2, and you get 83 degrees. Okay, make sure you put degrees also. So I ran out of room here, but 83 degrees, 144 degrees. And that's it. Just make sure that you're accessing this. So when I said 2 questions ago, do this question properly, the equation that you're going to get is from that work there, or sorry, from the formula sheet there, because you will have access to it. Okay, good luck. Hope that makes sense. Like I said at the bottom here, your work has to be a little neater than mine. Okay, so my work, I'm showing you the work. You're gonna clean it up and put it in the right spots, for example, and not, you know, I don't think anybody wants to see this, right? So the markers are going to want you to use a ruler. They're going to want you to space things out properly. They're going to want you to go, you know, your thoughts. If this is your thought, let's find this first. Or sorry, let's find this first, and then let's find this. Don't put this over here and that sort of thing. I kind of set a bad example, but again, I'm restricted on space here. I can't access the bottom of the page here, but you'll have lots of room. Okay, and that's it. Any questions, send me an email. Take care.